Okay. So quick review of what we were talking about last week. Okay, you got ionic compounds. If we're naming ionic compounds, okay, an ionic compound has what things in it? A metal and a non-metal. All right. Okay, naming rules are simple. Don't change the name of that. Change the ending of this to "ide." Okay, and then you got the whole drop and swap thing. If we got multivalent metals, then those ones require Roman numerals. We talked about that last week as well. And basically, you just have to use the charge on the non-metal to figure out the charge on the metal. Okay, and then you put in the appropriate Roman numeral. Then we talked about polyatomic ions just briefly. Okay, so you still have, like, let's say a metal. Okay, but then it might be joined with something like this. Okay, and okay, we would name that simply calcium phosphate. Okay, we'd name the polyatomic ions exactly as they appear in the table of polyatomic ions. Okay, when you do your drop and swap, which is what I did there, okay, if you require another number, okay, when you drop and swap, because calcium's a 2+ and phosphate's a 3-, I'm pretty sure, okay, then you have, when you put your number here, you have to make sure you enclose the ion in brackets, otherwise it's PO42, which is not the same thing as brackets 2, okay. So just make sure we're keeping that in mind. We're going to practice some more of that here in the coming days. All right, then we left off with our molecular elements. Okay, and those are molecular elements, molecular compounds, not molecular elements. Until I haven't drank all of my coffee yet. Molecular compounds. Okay, so we have 2 non-metals in those. Okay, and the first non-metal is named exactly as it appears in the periodic table. The second non-metal ends in "ide." Okay, do we swap and drop anything? No. Okay, what else do we use in the names? Prefixes, except for which prefix? Sometimes mono on the first one. Okay, seems like we remember it all. All right, so let's try 5 through 10 then. Give you a couple minutes to get ahead of me there. All right, so for number 5, I've got phosphorus, there's 2 of them, and I've got sulfur, there's 3 of them. So what are we looking at for a name here? Right, diphosphorus trisulfide. Okay, and for number 6, I've got oxygen and sulfur, but there's only one of each. Oxygen monosulfide. Good. Okay, number 7, I've got 3 silicone and 4 phosphorus. Let's try Austin. Right, trisilicone. Is it phosphate? Phosphide, right. And that's a tricky one because phosphate seems like one we should say because it's something we hear more often, but phosphate is PO4. It's a polyatomic ion. Okay, sulfur with 2 chlorines. Let's try Gareth this time. Right. Okay, number 9. I've got silicone with 4 hydrogens. Okay, and last one, I've got 4 borons and 3 carbons, and this one can be a little tricky. How about Cody on this one? Mm-hmm. Carbide, exactly. We shorten it. It's not carbonide, although I don't think it would be wrong if you wrote it that way, but typically we write it as carbide. Okay, questions on any of those? Is that making some sense? Okay, now it's a little easier when we know the entire list is all molecular. Okay, the challenge comes when I give you a list that has some ionic, some molecular, some that need Roman numerals, some that have polyatomic ions, and having to identify which one's which. Okay, the trick first off, to identify whether it's ionic or molecular. There's something ionic compounds have that molecular don't, which is metal. If it has a metal, apply the ionic naming rules because it's definitely ionic. There's no molecular compounds that contain metals. Okay, obviously hydrogen being an exception there, but hydrogen in a molecular compound is listed second and it's behaving as a non-metal because it can do both. Okay, all right. We just talked about that. Okay, so here's your list. Okay, this has some molecular, some ionic, some with polyatomic ions, some that need Roman numerals. I think there's only one that needs a Roman numeral in there. Okay, so give those a try, and then we'll go through them together. Okay, so number one, is it ionic or molecular? It's ionic. Lithium's a metal. Okay, so this stuff is just lithium chloride. All right, number two, ionic or molecular? Ionic, okay? And we have chromium as our metal, and it has more than one possible charge, yes? It can be a 3 or a 2, so what do we need in its name? We need a Roman numeral, okay? So when we're looking at this, fluorine is always a -1. That means chromium has to be +3, okay? Because there's 3 fluorines here, right? 3 times -1 is -3, so our single chromium's got to give us 3 positive charges. So we have chromium, Roman numeral 3, fluoride. Okay, number 3, ionic or molecular? Molecular. Okay, so we've got 1 phosphorus, 3 bromines, so we have phosphorus tribromide. Okay, and number 4, ionic or molecular? Tiana. Zinc? Ionic, okay, and what do we call it? Zinc iodide, exactly. Okay, questions on the first 4? Okay, keep going then. Give you a few more minutes. Probably get a little bit stuck when we get to the polyatomic ones, but we'll see. Okay, let's try 5 through 8 here. So number 5, ionic or molecular, Janae? Molecular, okay, and what are we going to call it? Okay, silicon dioxide. How many people are remembering not to use capital letters? Good. Okay, number 6, I've got carbon and sulfur. How about Max does this one for us? Excellent. Carbon tetrasulfide. All right, number 7, technetium with iodine. Let's have Noah try this one. Right. Technetium is one of the first, or was one of the first, man-made elements. Okay, and number 8 is our first one containing a polyatomic ion. How about Cameron does that one for us? Okay, so what's Na? Okay, so we got sodium starting off, okay, and because we're going to name it just like an ionic compound, because it is. It's a metal first. All right, then we look on our table of polyatomic ions for this combination. How do I know I need to look at my table of polyatomic ions? There's 3 elements. Okay, if there's more than 2 elements, you have a polyatomic ion somewhere. All right, so then you need to look in your table of polyatomic ions for OH, which is hydroxide. Okay, so we simply call it sodium hydroxide. You have probably encountered this stuff if you have ever used oven cleaner. Okay, this is the active ingredient in oven cleaner. It is a extremely strong base, pH of about 13.5. Okay, you spray it on the inside of the oven and it quickly dissolves any and all crud that has baked on the inside. You do not want to get it on your hands because it will quickly and easily dissolve that too. Okay, and if you inhale it, you will be coughing like crazy. It is a respiratory irritant. Okay. All right, how many people are done to, let's say, number 12? Okay, we'll give you a couple more minutes and then we'll look at those because many of those involve the polyatomic ions. All right, let's have a look at number 9 here. Let's have Chris tell us this one. We got calcium with, no, polyatomic ion, SO4, sulfate. Okay, so we got calcium sulfate here. Okay. Again, all you got to do is if you got more than 2 elements, just look up in that table and find that combination of elements that's not the metal, okay, and you will have your polyatomic ion. All right, number 10. Let's have Claire tell us this one. Permanganate. Yeah, it's a tricky one. Okay, potassium permanganate. Interesting stuff. Purple crystals. They're very pretty, but you shouldn't touch them because when they dissolve in the oils on your skin, they react and they turn brown. Not a nice color brown, like a brown you don't want on your fingers because people will wonder where your fingers have been. Okay, it's that color brown, and it stains for weeks. It doesn't come off short of bleach and sandpaper. Okay, you'd have to exfoliate quickly to get it off, right? And I tell you this because I once had a kid that I taught way back in my second year of teaching in Lloydminster. Never listened to a word I said, never. And we were going into the lab and we were doing something with potassium permanganate. I don't even remember what now. And I told all the students, make sure you don't handle that stuff with your bare hands. Use the scapula, whatever, don't touch it. He comes up to me with the little tray of it. And he's doing this. Mr. Clare, these are so cool. These purple crystals. I'm like, yeah, they are. Have you looked at your fingers? Oh! Can I go wash my hands? Sure, go right ahead. And it's not coming off. It was on there for weeks. It was so funny. Okay, like his thumb and his first 2 fingers, and they had this and it was just awful. Like it was almost a perfect ring around the first knuckle. It was disgusting, and it was so funny because he so deserved it. He listened a lot better after that. Does it happen in what? It could be. I've never heard of that experiment, but yeah, it sounds like it could be. Yeah. So they actually used to use this as a fungicide. They would make a solution of it, which would stain your feet, but they used it to kill athlete's foot back in like the 40s and 50s. Especially with soldiers, they would come in. They'd been in the trenches for a long time. In wet boots, they'd have horrible fungus on their feet, and this stuff would kill it. I mean, now granted, you're going to put socks on, and no one's going to see your feet, but it would stain their feet, but it would kill the fungus. So it was useful for that. Okay. As an aside. Okay, number 11, we have nitrogen and oxygen, ionic or molecular. Matt. Molecular? What's the name of it? Nitrogen monoxide. Okay, and number 12, I've got beryllium with cyanide. Let's have Blake try that one. Beryllium cyanide, great. Okay, and number 13, we'll have Beatrice try this one. Barium cyanide, right? So the real trick to the polyatomic ions in naming anyway is just finding them. Okay, once you've found them, it's just writing them down. You don't have to change anything about them. It's a little trickier when we're writing the formulas and we got to remember to use brackets or not use brackets and that kind of stuff. Okay, and 14, we actually did that one as our example last week. That's baking soda, but don't write baking soda. Okay, it's sodium hydrogen carbonate. Okay. And Jack, we'll have you try the last one. Okay, not potassium, tricky though, because potassium is actually K. This is phosphorus tetraoxide, right. Now, how many people wrote phosphate down for that one? Okay, because I see that happen sometimes, because this is what the ion phosphate looks like as well. Okay, this is a weird one, but this can exist as a compound, but it can also exist as an ion. If it's written like this with nothing attached, it's a compound. If there's something in front of it, then it's an ion. Okay, because an ion is a charged particle. A compound is not. Okay, so an ion like this doesn't just hang around by itself anywhere. You'd never see it alone, right? Whereas these you could, right? So phosphorus tetraoxide. All right, questions on how that works, Peter? Yes, here it has a net charge of 0. It doesn't. Remember, it's a molecular. This is a molecular compound, so it's not about trading the charges, right? They're going to share them. They're going to share the electrons. Yeah, that's why it can act as an ion, phosphate, right? Or yeah, as a compound itself. Okay. Now, the opposite. We've been working on naming. Now we got to look at, I'm given the name, how do I write the formula? Because honestly, that's what you're going to do more often. Okay? More often than not, you're going to be given a name, or a reaction is going to be written out as a sentence, like hydrogen chloride reacts with sodium hydroxide and produces what? Okay? And you've got to be able to write them down, figure out what they produce. We'll be at that in like 2 weeks. Okay? So first off, we got to decide, is it ionic or molecular? Well, it's easy to tell the difference because ionic compounds have to have what in them? Metal. Okay, so if we find that it is an ionic compound, then we write the formula for the metal and indicate its ionic charge. So let's just say that the compound we're given is written like this. Okay, calcium phosphide. It's an ionic compound because calcium's a metal, right? So I write down calcium and I write its charge 2+. And then I write down the nonmetal and its charge, phosphide, -3. Now what do I do? Drop and swap. I've got the charges, so I drop and swap. So the 2 goes here and the 3 goes here. I can get rid of those. Can I reduce 3 and 2 down to anything? Then that's as far as I go. There's my formula. Okay, by doing that, I've balanced the charges. The reason the swap and drop works is because it makes sure that you have -3 times 2 is -6. +2 times 3 is +6. It makes sure the charges are balanced. Okay, it works out for you every time because it's cross multiplication. Okay. All right, does that make sense to everybody? Okay, writing the formulas for ionic really is pretty easy unless you run into one that you forget to reduce. I'll oftentimes see people leave something as like 2 and 4 or 3 and 6, and they'll leave it that way. You got to reduce that down if you can. Anytime you can reduce, you should. All right, what if instead of one like this, we get this? What if I get that? Magnesium hydroxide. Okay, I still follow the same rules. I write the metal, magnesium, and its charge, 2+. What's hydroxide? Just got a little dash beside it, it's -1, right? Okay, so hydroxide is a polyatomic ion. Okay, so we look at that and we write its charge, -1. Now I carry on as I did before. Okay, I drop and swap. So the 1 goes here, but we don't write 1s, and the 2 is going to go here, but what do I need to put around OH? Brackets, because if I just write a 2 here, it says there's 2 hydrogens, not two hydroxides like that says. So in a swap and drop of a polyatomic ion, if you have to put a number down, you got to put it in brackets. Okay? If it's something like phosphate, like this, and you need to put another number here, this number doesn't change. A lot of people do that. It's a common mistake. They try and change that number. That's what phosphate is, PO4. If you change the 4, you change it. It's not phosphate anymore. Okay? All you can do is enclose it in brackets and add, let's say, another number. Okay? Whatever it needs to be. Everybody follow me there? That's the most common mistake that I see in this. Right? Now, make sure that when you're looking at your table of polyatomic ions, you look closely at the top because the way it's written is a little different. Okay? If it just has a dash, that's -1. All right? The other ones will be like -2 or -3 or whatever. Okay? Those will be the charges. If it just has a dash, it's -1. All right. If we have molecular compounds, then the numbers tell us, okay, or sorry, the prefixes tell us what numbers we have. They're really easy because, right, let's say we have this. I don't even know if this is a real compound or not. I'm just making something up. Okay, dinitrogen monochloride. It probably isn't, but let's just say it is. Okay. All I do is I look at the prefixes. Dinitrogen, that means N2. Monochloride means just Cl, only one. Okay, N2Cl, that's probably not a compound, but okay, that's how the naming goes. Molecular, really easy because the prefixes just tell us what numbers to write in. What if you got a situation in one of these where you had a 2 and a 4? Would you reduce it then? No, you never reduce molecular ones. The prefixes told you this is how many. Remember, you don't reduce molecular because they're not balancing charges, right? That's how many there have to be in order for the charges to be shared, right? So we don't reduce molecular compounds. All right. Now, I'm going to hand out, I got a couple of worksheets here for you guys to practice this on. Okay, I think we'll get through them pretty quickly. So I'll hand those out first, and then I'll talk about where you can find your answer keys and stuff. But when you're doing these, please don't do more than 5 before checking your answers. Okay, I'm going to show you where the key is. It's on my website, so you can just call it up on your phone or whatever. Okay, and just check them as you go. But don't do more than 5 before you check, because if you're doing something wrong, you're just going to practice it wrong over and over again, and that's going to become a habit that's hard to break. Okay, so do 5, check them. Do 5, check them. Okay, if you get one wrong, don't just correct it. Okay, look at where did you go wrong. If you can't figure out where you went wrong, then call me over and I'll help you. Okay, but we want to make sure that we're not just, well, it's just supposed to be a 4 and I put a 3. Doesn't matter. Change it. Okay, that's not going to help you learn why you put the 3 and why it was supposed to be a 4 or whatever the case may be. Okay. Right, that's the danger of giving you a key, is that people just go, oh, change it, or or people think they're really clever and just copy down all the answers and so they're done, except they don't learn anything that way. Okay. Most of the time when I give you a worksheet, well, I shouldn't say most of the time, but in some situations, especially in like the physics unit or something like that, I'll have the answers right on the worksheet so you can check as you go. You're not handing it in, so it's okay to put the answers on there. That way you can just check and see if you did it right. But in one like this, having the answer right beside it kind of defeats the purpose of having you try it yourself, because it's just, writing something down. So you can find the key on my website, which hopefully you've bookmarked on your phone. Okay, because this is the only thing you'll probably use it for, okay, is to check the answers to things. So if you go to my website and you go to Science 10 Stuff, and you go down to the chemistry folder, I will probably post it today, yeah, but I haven't posted it yet. I probably won't post it till the end when I do this, right? So the keys, I believe, are down near the bottom here. Yeah, naming key 1, naming key 2, naming key 3, naming key 4. Okay, so they're all there. I don't remember which one's which, but it won't take you long to see whether it matches the sheet you have. Okay, so that's where you can find them. Just click on View rather than Download, and you'll have them there. Okay, like I say, do about 5, check your answer. Do about 5, check your answers.